Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with numbers 16, 17, 18 on your Unit 2 homework here. So let's see, number 16, an airplane is built to withstand a maximum acceleration of 5 Gs. So let's start with that. So this is just kind of slang, is what I call this. So 1 G of acceleration is an acceleration of 9.8 meter per second per second. So an acceleration of 5 Gs would be 5 times this, a little less than 50 meter per second per second. So calculate that, get a number in units of meter per second squared. Let's see, what size force would cause this acceleration? So this is a Newton's second law question. So let's write out force equals mass times acceleration. And then the acceleration you're going to get from earlier, and then the mass is given in the problem. That number will come here. You'll get a really big number, and when you work out the units, it will work out to kilogram meter per second squared, and that's what a Newton is. So we can also just express this number in newtons. A Newton is a very small unit of force. It's roughly 1/5 of a pound, so you're going to get probably a pretty large value for this. All right. Next on the list, 17, let's see. Under certain conditions, the human body can safely accelerate up to 10 Gs. So start by calculating an acceleration, which is 10 times 9.8 meter per second, and get a number. And then what force would cause this? So we write out Newton's second law, force equals mass times acceleration. And the mass is given in the problem, and you're calculating the acceleration a little earlier. Part B, where it says find the weight of such a person in pounds, then convert your answer to pounds. That doesn't really make a whole lot of sense, does it? Well, part B, where it says find the weight of the person. Find the weight of a person in pounds. So weight, right, is equal to mg. So you're going to take the mass that you're given. In the example I'm given, this is 62 kilograms. Yours might be different. Times 9.8 meter per second, and you're going to get a number, and that's going to come out now in newtons. And that's going to be one of the answers there, where it says weight of the person. Oh wait, it says find the weight in pounds. All right. So once you find the weight in newtons, then you're going to look up the conversion factor to go back and forth between newtons and pounds. So you're going to take that number in newtons, then you're going to multiply by your conversion factor, which has pounds up top, newtons in the bottom. And I'm not going to spoil what that is. I'll let you go ahead and look that up, and you'll get the weight in pounds. Then the last one, where it says find the net force from A. Oh, in pounds, now I get it. All right. So for the very last question, you found the net force earlier in newtons. So you'll have a number in newtons. And then you're going to multiply that. And then you're going to take that number in newtons and multiply by a conversion factor that has units of pounds per newton. You'll look that up, and you'll get the net force in pounds. So that should get you through 17. All right, let's see. 18, a spacecraft approaches a planet. The rocket engines are on to slow it down. It will go into orbit around the planet. The spacecraft is 2,025 kilograms, so there's a mass given. Yours might be different, but that's the one given in this problem. The rocket engine slows the object with a force of 405 newtons. Yours might be different. Let's see, if the speed must decrease by 1,109 meters per second, how long must these rocket engines be fired. So let's start with this. Write out Newton's second law, force equals mass times acceleration. Now, these are examples of what are called vectors. And there's a little bit to this. So the rocket, let's say, is moving in this direction. So I'm going to put a V here for velocity. This rocket is slowing down, meaning that the force, this 405 newtons, is pointing this way, opposite of this, of the velocity to slow the rocket down. So generally speaking, what we do is if we call this way positive, then this way we would call the negative direction. So what I would do is put a negative number here for this. So let's write it like this: minus 405 newtons equals m, and the mass is given, times a. And when you solve this for the acceleration, you're going to get a negative number. And all that means is the acceleration is opposite of the velocity. Then you draw a velocity graph for this. Let's see, the speed must decrease by 1109 meter per second. So the velocity graph is going to look something like this. But it doesn't really give this. This initial velocity is not a known value. So I guess we're not going to be able to use this to find the slope. But what we can do, remember that acceleration is change in v over change in t. So whatever number you get for this, and it's going to be a negative number, you can go ahead and put that there. And if you read the problem, it says if the speed must decrease by 1109 meter per second. Yours may say a different value, but mine says 1109 meter per second, and it says decrease. So in my example here, you would put minus 1109 meter per second because it is a decrease. And then you're going to solve that for the delta t to figure out how long the engines must be fired. So I hope that gets you by in this problem. I hope you're having a great week. And if you need anything, don't hesitate to get a hold of me. Have a great day.